Thank you everyone for joining. It's such a pleasure. In this following session, I'm going to talk optimizing engineering efficiency through observability in our modern applications. Just quickly to get introduced to everyone. So I'm Ran Ribbenzaf. I'm the co-founder and CTO at Hexagon. And you can follow me on social, Twitter, LinkedIn, and everything. I love to speak about technical stuff, serverless, the ecosystem of microservices, observability, and everything. So really feel free to ping me over there if you have any other questions. So let's get going. And just, to set the expectations, today we're going to speak about the observability ecosystem and specifically what's the rise of microservices and how it impacts our day-to-day work with our engineers. Also the challenges that are associated with this kind of new architectures, new patterns, new software that we're delivering, and how do we overcome them? What's going to be our strategy? How do we do observability and what's observability? And ultimately, the impact for the business when we're having or not having an observability solution. So now that we covered that up, let's talk about microservices. All of you in the room are probably familiar with that. It's not something new, but I just want to set a baseline to understand what we're speaking at. So back in the days, we used to have monolithic applications. Monolithic applications included, all of our services combined all together into a single binary that is running on some specific service. And when we wanted to change something, even the smallest thing, everything got deployed into production. It took us maybe, I'm speaking for myself, but maybe days of deployments just to change something small. And today the concept is a bit different. It's more towards microservices. It means that each business unit or each business logic is separated into a different piece, different kind of software that's deployed independently into another environment. It can be composed with containers or cloud or serverless or any other place. And altogether, it brings us the values of, or the benefits of, rapidly deploying much faster. You don't need to be dependent on the other services. You can also scale up and down only the relevant services. And ultimately, it gives freedoms to our teams to work on just what they need to work instead of knowing all of the system. And if we're looking on it on a visual, what it takes, so there are two main parameters or two main characteristics that we're looking at, moving from the monolithic applications to microservices and then the cloud 2.0 applications that we're having. So one of them is where the application is running and what's the composition of the application. So we're seeing that we're moving from host-based towards abstracted host, containerized environments, orchestrations, cloud native elements, and also from monolithic to a super distributed application composed with hundreds of resources, and it's getting really complex to understand it. While it has a lot of benefits of microservices, it do introduces something which is a bit kind of a downside to it, and it's the complexity, the growing complexity that we're facing. So far, if we had a problem, we were getting into the same application, the same server, and we would know exactly what happened. But now the problem can be spread across hundreds of services or tens of services, and how do I know really what happened and where it happened? So the new challenges that our engineering and DevOps teams are experiencing, starting even from development, when they want to develop a new feature, how do they know how it interacts with other services? What's the change that they've done, how it impacts other things? And so how they can implement faster things, and that's something that really impacts our development velocity and our efficiency of our engineering teams. Also not talking about general monitoring. Is everything working properly? And what's everything? Now it's not just a single application, it's tens or hundreds of services. And ultimately when something goes wrong, and as we all know, something goes wrong, we need to be able to roll our sleeves and get into the problem. So we need something that will help us troubleshoot much faster and in an efficient way. To that exactly, observability comes into the help. So observability, in other words, consists with three pillars, metrics, logs, and traces. All of them are kind of techniques that helps us to understand our system, to troubleshoot it, to monitor it. And only by combining all of them together, you can really be in a state that you can observe your system. And in other words, not getting into too much of the technicalities, but to understand the system, metrics tells you what happened. For example, a spike in a CPU, error rate that is going up, very strikingly. And then you need to know what happened, why it happened. So you're getting into the logs to look at the actual log lines to read through the logs why exactly is the problem happening. And then when you need to understand where it's happening, because now again, it's not a single service, it's hundreds of services, Traces tells you exactly the path of the request and what happened, why it happened, in where each and every resource along the path. So all of these are really crucial to gain real observability into the system. And traditional tools today doesn't really provide the ability to do all of this, because usually you find yourself first with one tool for logs and one tool for metrics, which are just not enough. They don't construct the whole picture, the bigger picture of how resources are communicating with one another. And then most of these solutions are based on agents, which are providing somewhat limited visibility into the actual application level data that is going on, and also can be very costly on super distributed environments where you need to deploy hundreds, if not thousands of agents at various levels. And also the main problem, and I think that really touches our main kind of discussion here, is that when you want to make your engineering teams more efficient, you want to remove anything manual that they need to do. And logs, really, it's a manual work. Your engineers need to go line by line to log what happened and how it happened and create correlation IDs and do tracing. It's a lot of manual work that kills your team, kills the agility. You don't want to end up in this place. So let's talk about the most interesting part over here at observability, which is the distributed tracing. As you already know, everybody got monitoring in place and got logging in place, but distributed tracing is really the awesome part that becomes very important in nowadays applications. And in other words, you know, a trace, as you can see on the right-hand side, is just a story. All it's telling is a story of how an incoming request came with some error, and we got a message going through a Kafka message queue topic, and then another service reads it, and some other services are taking part. So distributed trace, in other words, is just a story how an event is going in our system. And that's good, because using distributed tracing and using all of the observability pillars, we can come into what we're calling the best practices of observability. And I think, you know, if we're taking one step back to talk about what's the state should be, or where do you need to find yourself as an organization today, is with a solution that completely brings, obviously, all of the observability pillars, but in an automated way. You don't want your engineers to spend days or even weeks implementing solutions manually, one step by another. So the solution that you should look for is something that completely brings the picture all together in an automated way. No training, no maintenance, no anything required. Also, it should definitely be something that supports your modern environment. So, you know, Kubernetes, ECS, cloud-based applications, function as a service, serverless, all of these buzzwords are, you know, becoming real, and you need something that supports all of them together. You want to have something that connects all of the dots, like doing the distributed tracing for you in an automated way. You don't want to spend time understanding how one thing correlates to the other thing, definitely not manually to do. And also something that helps you search and analyze your data. As you can see on the right-hand side, an example application running on AWS, there is a ton of data that is coming in and out. You really need to look into the data. For example, how many kinds of these errors am I having, or how many customers am I having in my application? All of this should come with a good observability tool and not in a manual way. And ultimately, you know, one of the major pain points that we described when moving to microservices is how do we pinpoint this kind of problem? So we want a solution that will take you from what exactly happened over here to I know exactly, and I'm already working on a fix in a matter of a few seconds, or, you know, a few minutes at most, and not something that will take you hours, because that's too long and downtime can be very costly for our applications. Now, as a CTO, that's talking to, you know, directors, CTOs, leaders in organizations, the path for observability is not as easy as I mentioned, and it consists with several steps. So I would love to take you through what it takes to get into this Zen mode, or the state of observability. So first, identify what's your business goals. Understand where you're lacking today. Is it troubleshooting? Is it monitoring? Are you moving from monolithic to microservices? What's your goal as a business to improve? If it's engineering efficiency and you find yourself, you know, engineering talking in the hallway, oh, damn, I'm always troubleshooting problems and it takes so long, or I'm spending too much time on development environment to understand what exactly am I doing and whether it's right or wrong. that's a good thing to put as a business goal to make it better. Now, once you know what's going on, understand what's your approach, whether it's do-it-yourself or managed solution. That's a super important step to decide. And by the way, you don't have to decide necessarily at the first point. You can evaluate several tools, but you need to understand very early in the steps, are you going on the do-it-yourself or a managed? And I'm going to talk about a few words about the do-it-yourself right later on. Also, implement and evaluate several observability solutions. That goes without saying, don't go just with the first one or the one that looks like, the top notch. Understand what exactly really fits your needs, and then understand if it answers all of your strategy, as someone that leads the company to a better place in technologically wise, understand whether it fits your exact needs. Now, we're talking mostly about the technical stuff, but let's talk about the business level, or what's the value of gaining observability into your business. And I think that the main challenges we already described, but I'll review them very briefly and, talking more about what's actually the pain points. So the complexity in modern applications, again, moving from 1, 2, 3 services to hundreds of them, really hard to do. And you probably already have tools in place that you're trying to abuse or, hack into the modern environment. It just doesn't work well. It might work on the, very few days, but you need some better strategy and better tools that fits the modern environment. And if you find yourself with engineering teams spending a lot of time of troubleshooting, that's something that you need to, be aware of and know that you can do this faster, and know that you can do this much better. And also, when we're talking about observability, it goes without saying that our business is the most important thing to observe, and our application is just a mediator between what we implement to our business. So we want to measure the customer experience and understand the business impact that our application is doing. So if we don't have any observability to that, it almost means that we know the application is running, but we know zero about what it delivers to our customers. So that's another challenge to solve. Now, when using a good solution, and again, this can go do it yourself or a managed solution, first, the main impact would be faster development cycles, faster development velocity. You'll ship features much faster because your development lifecycle would be just easier, simpler, and faster. And also, you'll reduce the downtime because troubleshooting now, instead of 1 hour, will take like 2 or 3 minutes. And you'll also understand the customer journey in your website because you'll see how when a customer interacts with your system, how it goes through different services, how long it takes, where are the bottlenecks, and what exactly happens. And in general, if we're talking, not just a single customer, but overall for all of the customers, a good solution will give you a complete visibility into all of your resources, all of your bottlenecks, your issues, your performance impacts, and what exactly is going on. Now, we want to enable, visibility across microservices for all of the teams. So I think, just reviewing quickly the challenges. So when having different tools, it means that it impacts our engineering and DevOps teams because now they're using one tool to monitoring the Kubernetes, let's say Prometheus, and Grafana for the other some things, and then CloudWatch metrics, and then some Splunk or Elastic or some another solution. All of this correlation becomes very hard to understand, and especially when it comes with sampling, you have blind spots in your applications, which results into blind spots when you're doing root cause analysis. Now, when doing observability in a good way and finding the right solution that fits modern applications, again, as I mentioned, you'll reduce the application downtime. You will remove any lost revenues because it took you 2 or 3 hours to understand the problem. And unified observability tools really help teams to collaborate all together. There's always the thing that it's not our problem. Our solution, our monitoring solution says everything good. It's team B problem. And team B says the exact same thing. It's not our problem. We got it all right. It's team A. So when having everything under the same solution, there is no blind spots. There is no dead ends. You see exactly everything from end to end. And also when we're talking about the, operational or the development costs that we're having, the legacy APM solutions really create a lot of impact into our applications because when it used to be one agent, lives on one server, it was okay, but now it's hundreds or thousands of agents very much consuming our environments. That's not a thing that we want to consider, to spend 10 or 20% of our infrastructure utilization just for monitoring. And also it can get very expensive because the pricing is usually based on number of agents or number of hosts multiplied by number of gigabytes that we're transmitting, multiplied by so many factors that we can just don't really understand. And ultimately, we don't find ourselves with a good solution. So a good outcome for a good observability tool that fits the modern applications is, first of all, that everything comes in an automated way. You don't need to spend time on training or maintenance for this kind of application. And that point I really want to touch with some more personal notes too. When you're choosing a do-it-yourself solution, you need to take into consideration the total cost of operations, because you need to take care for the scale and the implementation wise and training and going through the teams and deployment cycles. There's a lot of heavy lifting that managed solution took out of the equation, that getting the adoption much faster, paying the total cost operations in a much smaller amount. So ultimately that can lead to a reduced cost for monitoring solution, reduced cost for troubleshooting errors, reduced cost for development, because now the engineers are not being busy to implement observability solutions, they're being busy to implement business solutions for what the business exactly needs. So that's, again, another good outcomes when choosing a monitoring solution. And I think I touched on some points what the preference for do-it-yourself or a managed solution. So just to wrap it up, businesses are moving from monolithic to modern applications. It's becoming distributed. It's becoming event-driven. It becomes very complex. And the existing solution just don't have the good kind of attitude to solve this kind of problems. They used to solve one problem. It just doesn't fit the new problem. And it's not something that you want to build on your own, because if your business is doing retail, you're probably not the best at observability or monitoring. You want to do retail. That's what you're best at. Do something that will be good for your customers. So a good observability solution, one that fits, will allow your teams to even move faster and ship faster and better software for your application, for your company and your business. And ultimately, try to come up with a good observability strategy once you're leaving this conversation. This will lead your organization to better outcomes, better results in the near and the longer term future. So thank you again, everyone, for joining. As I haven't mentioned, but Hexagon is doing exactly this observability. It will help you with the strategy. Personally, myself would love to help you with any questions, any issues, any concerns through the social media. But feel free to evaluate Hexagon and understand whether it's something that fits your needs. Thank you very much, everyone, for joining.